We now talk about magnetization and magnetic intensity. So the magnetic flux density is obtained due to external factors. So the external factors could be current and internal factors. So these internal factors could be property of the material. So you can imagine that iron and silk and rubber and glass, all these would have different internal factors and the current applied to them could be the same. So we rewrite magnetic field, or we should say magnetic flux density, as mu naught times m plus h. So this h comes from external factors and this m comes from internal factors. So we say h comes from external factors which are like electric current, and m's comes from the inherent properties of the material. Now what you do now is you take h outside. So you could write magnetic field here, or more likely as magnetic flux density. You take this h common and you put m over h as chi. So this becomes equal to mu naught times chi plus 1 multiplied by h. So chi plus 1 you write as mu r. So this becomes mu naught times mu r times h. This chi is called magnetic susceptibility, and mu r, this is called magnetic permeability. So we have obtained a new formula for this magnetic flux density. So this B is magnetic flux density. So the new formula for this is, this B is equal to mu naught times chi plus 1 times h. This is also equal to mu naught times mu r times h. So again, chi is magnetic susceptibility and mu r is called magnetic permeability. We now talk about magnetic materials. So there are three kinds of magnetic materials: diamagnetic substances, paramagnetic substances, and ferromagnetic substance. We start by talking about diamagnetic substances. When a diamagnetic substance is placed in an external magnetic field, it acquires magnetism in the direction opposite. So notice the direction is opposite of the magnetic field. So that means if you place a diamagnetic substance in a magnetic field, it gets repelled by the magnetic field. The examples are copper, gold, and silver. And for such materials, this chi, magnetic susceptibility, is less than 0. Now we talk about paramagnetic substance. When a paramagnetic substance is placed in an external magnetic field, it acquires a magnetism in the direction of the magnetic field. So it basically, if you place a paramagnetic substance in the magnetic field, it gets attracted towards the field. So for these, chi is greater than 0. But the value of chi is small. So although there is attraction, the attraction is really small. So examples are aluminum and manganese. Now we talk about ferromagnetic substance. Now when a ferromagnetic substance is placed in an external magnetic field, it acquires a magnetism in the direction of the magnetic field. Again, chi is greater than 0, just as in paramagnetic's case. But this magnetism here is much stronger. So if you place a ferromagnetic substance in a magnetic field, it gets attracted towards the magnetic field. But the attraction is much stronger compared to the paramagnetic substance. So the example is iron, nickel, and cobalt. So now we talk about Curie's law. Now if you raise the temperature of a substance, so you have something like iron and you keep heating it above a certain temperature, which is above a certain temperature which we call the Curie point. So above Tc, we will have this law where the magnetic susceptibility chi, so chi is the magnetic susceptibility, it is inversely proportional to the temperature. So as you increase temperature, you start reducing the magnetic susceptibility. So basically you could make a ferromagnetic substance into a paramagnetic substance if you keep heating it. So for example, if you keep heating iron at extremely high temperatures, it will become a paramagnetic substance because chi will reduce, and chi is really small here in the paramagnetic substance. So in terms of graph, it looks like this. So you have chi on the y-axis and you have increasing temperature here. So once you're above this Curie point, then this chi starts decreasing like this as you increase the temperature. So you can say chi is inversely proportional to the temperature, and this temperature has to be greater than the Curie point.